discussed this slide, but I'll just brush you up that when we were discussing about climate change, then we discussed on how it was affecting the human exposures, especially on the human exposure. So therefore, in the form of weather changes, weather pattern changes, and as a result of those changes in the weather, now prime change that is happening in the climate is changing temperature. Now with that change in temperature, the ocean currents and the atmospheric currents, their chemistry had changed, and as a result of which the overall weather pattern of the globe had changed, with which the changes in the other features had also occurred. So what are those changes? So those are in the changes in the precipitation, in terms of extremes of weather pattern, in terms of heat waves, and because everything had evolved during course of the several years of course of time, keeping in mind all those physical factors that were provided by the nature. Now, when the sudden changes had started happening in these physical factors, then of course they are going to affect the organisms also in there. So either those organisms won't be able to adjust themselves at such a sudden change, and therefore they will start dying, as a result of which the biodiversity is declining, and the species are getting extinct at a very rapid rate. And not just this, but even the microorganisms or pathogens, there are likely chances that some of the microorganisms, bacteria, which were very good in in a way that they were good for farming and they were good for production, they will die, and some harmful pathogens, maybe some viral species which were not active in these temperature conditions, will become active, and they will start affecting the agricultural system, etc. Okay, and therefore they started affecting the food production, the water shortage, with the coming of new diseases and new vectors and new pathogens. And as a result of this, it started affecting and causing these problem of malnutrition, infection, and health impacts on the people. So this is how this climate change had happened, and they had started affecting one by one, from those physical changes in the physical factors, from the changes in the weather pattern, from the changes into the ocean currents. They had started affecting the the health of the human being, the health of the vegetation, and hence the basic requirements, that is the food, the health, and the diseases, they had started coming in a very, very new way. Okay. Okay. So then we also discussed about greenhouse gases, and we told that there are four prime greenhouse gases. Of course, water vapor is also a greenhouse gas, but we do not consider it as a greenhouse gas because it's a part of natural hydrological system. So it's there since time immemorial, and it is already there, and no human activity is there which is enhancing the production of water vapors. Okay, so those greenhouse gases which we are producing, or which human activity is accelerating its addition into the environment, then those are the gases which we have taken into account, and these are four. Okay, nitrous oxide, which is your N2O, methane, carbon dioxide, and fluorinated gases, and their percentage distribution is given here. Okay, and what are the chief causes for CO2 and methane and nitrous oxides? These are all fossil fuel burning. Okay, for nitrous oxides, of course, fossil fuel burning, and the causes for fossil fuel burning is what? Transportation, industries, and for other uses. Okay, now for the methane, of course, not they are also released from the fossil fuel when incomplete combustion takes place, but it also gets released from the regions where decomposition process is not in presence of good amount of oxygen, from marshy areas, from bogs. But again, we don't take into account the means the natural regions, because they were there since time immemorial. So those sources which have added to them, we take into account those sources for greenhouse gases. So for methane, these sources are in the form of wastewater treatment, or during that process methane is released, but that is very minimal. But mostly it's the industrial activity, and mostly by burning fossil fuel, this methane gas is there. And for the fluorinated gases, we will discuss more about it when we will discuss about ozone layer depletion. Okay. So then we also discussed about what is greenhouse effect. So we said that it's known as your greenhouse effect from the concept of your glass houses. Okay. So what these glass houses used to do, they used to capture the heat radiations that were coming from the sun, and with that heat, with that temperature rise, they were able to create somewhat tropical type of situation, which is good for the growth of vegetation. So this concept was good for temperate regions like Europe, parts of US, Canada, where the temperature are very less. So in order to promote the vegetation and the agricultural growth there, in the mountainous regions, in the hilly regions, there, with the help of these glass houses, they were able to create the sort of the tropical type of temperature conditions with which the plants were able to grow. The same concept we are applying onto the atmosphere, where this glass sheet is in the form of the atmospheric layer, which is composed of CO2 and water vapors. Okay, so natural are these with few percent of methane. Okay, these are the natural ones. Okay, then nitrous oxide, natural sources, of course, volcanic eruptions, but not much. Okay, chief percentage of the N2O in the atmosphere is because of the fossil fuel burning. Okay, so there we told that because of these industrial activity, these transportation activities, and other activities, they have started adding these gases at a very rapid rate. This glass house effect of these atmospheric layers had enhanced to very. They have they have increased several folds with which the temperature of the earth has started rising. And we have already discussed what is happening with the temperature rises, because everything is connected with this temperature rise. Okay. So we also discussed about how they were the reasons for the changes in the weather pattern, in droughts, in floods, and melting of the glaciers, and rising of the sea level, in the decline in the food productivity in terms of coming of new pathogens in the form of water shortage, because evaporation was happening, groundwater table was going down, and this had also led to the rising of food prices. Okay, so we can see that impact. Okay, although of course in India, the because of this COVID situation, we are seeing the rises in the food prices and in the commodities. But what about fossil fuel? This fossil fuel is now shooting in some parts more than 100 per liter. Okay, and this price rise in the fossil fuel is associated with the rise in food prices also, because transportation is the main mode, and in order to take out the profit, where this spending on high priced fossil fuel will go, that will be taken from the food prices, and that is why it will shoot the prices of the food in or the vegetables, etc. also. So this is why the inflation is also happening, because of these greenhouse effects or the pressure on the resources. Okay, so these are all the impacts of ocean acidification, normal means acidification, and loss of biodiversity, sea level rise, changes in the weather pattern, shortage of food, coming of new diseases, extreme weathers, and so and so. Okay. And then I had also showed you how CO2 rise had happened, with CO2 rise and the melting of ice, sorry, the rise in temperature and the melting of ice had resulted in rising sea levels. Okay. And it's not much time. I think since 1990, 1980s and 1980 or 1990 only we compare, we can find that their sea level was so low, and right now the sea level is very, very high. So it's increasing at a rate of about 3.2 mm per year. Now we may imagine, अरे ये तो बहुत छोटा सा rise है, such a small rise, क्यों इतना परेशान होना? Just imagine, huge amount of ocean is there. उस पूरे ओशियन में 3.2 mm राइज करने के लिए कितना वॉल्यूम ऑफ पानी मेल्ट हो रहा होगा? It's important thing is there, and this small rise or mm is enough to affect then submerge the coastal areas. Okay. Anyway, so this is the CO2 trend in the last few years. Of course, it's not the first time that the CO2 concentration has gone up so high, but this time it's not because of the natural causes, or it's not because of the changes in the rotation, revolution, or the radiation impact of the earth. It is completely because of human activity. So in each, so that I discussed this earlier as well, that what is the difference between the climate change that had happened in past several years and now. So the thing is that initially these changes had happened over years of time, over decades, over 100 years of time, and these same changes now are happening within 10 years of time. So this gradual increase shooting into sudden increase is because of the human activity, and that is why it is the problem, or it is something to be taken public against out, and it is something very concern, or of a matter of concern. Okay. Then we also discussed how the fossil fuel deforestation, they are associated with the production of the greenhouse gases, and with these greenhouse gases the global warming warming and climate change is happening, and ocean acidification is happening, and then all the changes in terms of habitat destruction, in terms of sea level rise, in terms of crop failure, in terms of melting of ice glaciers, and in the removal of the snow cover, etc., is happening. And these all activities, I mean, these all effects in turn are further increasing the CO2, methane and water vapor, which is causing a positive feedback loop. Okay, so once these greenhouse gases have produced, they have started producing the changes, which further enhances the addition of the greenhouse gases. Okay, fine. Anyone has any problem so far? Anybody? This is something which I had already told you in different classes, but I have still revised it. If anyone has any question, you wish to share anything, or you have any query, or there is something which is coming to your head, please share. Anyone?
No, ma'am.
Okay, thank you, Anita. Okay, so now we move on to two major impacts. One is we will discuss about what's acid rain, and then on the formation of photochemical smog. Although that's a part of pollution, but I take it here. Okay, so these two things, and then we will come on to another impact of the environment, that is your ozone depletion. Okay, so what is acid rain? Rain which contains acid means the pH of water goes below 5.5. Okay, and again, what is normally what is the chemical composition of any acid? It's H2SO4, that is sulfuric acid, or it's nitric acid like HNO3. Okay, now what when these acids starts getting produced in the nature, and how will they will be manufactured? When the source of nitrogen and sulfur is there in the atmosphere, which will mix them with the water to form and obtain this acid. So this is what is happening. Now, as a result of this fossil fuel burning from the industrial emissions and from the transportation, the sulfur dioxide and nitrogen oxide are being produced. Now, these are ingredients. These are the spices for your dishes. आपके खाने को पकाने के लिए ये बहुत बढ़िया, ये खाने में नमक और मिर्च का काम करेंगे. ठीक है. So ये SO2 और NO2 आपके दो इंग्रेडिएंट्स खाने के लिए तैयार हो गए, नमक मिर्च तैयार हो गए. एक अब इसमें सब्जी में पानी डालने की जरूरत है, जो पानी इन्हें नेचुरली मिल गया है, and the recipe is ready in the form of H2SO4, in the form of HNO3. Now the atmosphere already contains these vapors of H2SO4 and HNO3, जो कि suspended है. अब जैसे first rainfall होगा, what they will do? They will, उसमें भी पानी है, water vapors हैं, बचा हुआ sulfur dioxide और NO2 that will also get mixed and combined with these rainwater. So अब जो पानी धरती पर गिरेगा या जमीन पे गिरेगा, that is actually a cocktail of these two mixtures, H2SO4 and HNO3, a very good mix of acid rain. Okay? And acid, and because soil is alkaline in nature, उसमें आपका सोडियम, पोटेशियम और मैग्नीशियम मिनरल है. Calcium is an important mineral. It's part of our human body. Most of the buildings, they are made up of silica, which is your silicate mineral, which is again alkaline. All they will get reacted with this as acid formation. और उन reaction से everything gets degenerated, or everything gets degraded, or everything gets decomposed. Okay. Second thing is, so एक तो ये आपका पूरा soil खराब कर देगा, और जब soil खराब हो जाएगा, so can we imagine of anything getting produced from that soil? Already there is huge pressure on the soil. Now with these acid droplets or acid rain falling on that soil implies that this will turn soil into barren, because it will wash away, it will destroy all the alkaline matter and will kill the microbial organisms that play an important role in decomposition there. तभी उसको मार दिया, अभी soil में तो कुछ बचा नहीं, it will affect the productivity also. पहला, दूसरा, पानी में गिरेगा, water bodies में गिरेगा, it will cause acidification. और acidification से क्या होगा? The organisms in the aquatic organisms, they will start dying. Third, when they will fall on monuments, most of the monuments, they are composed of sediments, and sediments are again part of soil. Again, those minerals are there, they will get washed away with these acids. Okay. So we were discussing about one important case study, and an example in this is the Taj Mahal. Okay, this report was there when the marble was turning from white to slightly creamish and yellowish in color. Okay, so it was because of these acid droplets. Okay. Can anyone tell, or anyone knows that from where these acid droplets were coming to affect this monument of Agra?
Sorry, ma'am, what's the question?
Okay, Anita, my question is, now there is this important case study where The Taj Mahal in Agra, which is made up of
Ma'am,
marble.
acid rain.
Okay, thank you, Deepika. Okay, okay, I'll complete my question.
Yes, ma'am.
Yeah, okay, fine.
Ma'am,
So
characterizing.
this is made up of marble. Okay, so there was this report that the Taj Mahal is losing its whiteness, and it is turning slightly yellowish and creamish in color. Okay, so this was because of because this marble, which is of course your calcium carbonate, was reacting with these H2SO4 and HNO3 molecules. Okay, so my question was that, Anita, you had asked that from what is the source of these acid vapors there? So Deepika said acid rain. Fine. Pallavi also
Yes,
said same.
ma'am.
Yeah. Anyone else?
The
Mathura
Swiss
oil
ma'am.
refinery.
Very good. Perfect. Yeah. Thank you, Neha. Thank you, Payal. Perfect. It's actually the Mathura oil refinery. And oil is again a fossil fuel. So when they, okay, thank you, Vinita. Okay. So mostly it's, oh, although there are factories, but major impact is from this Mathura oil refinery because they bring the crude oil, and then this crude oil is sent into refinery to obtain petrol and to obtain diesel and to obtain tar and to obtain different parts, different sections from these petrol. Okay, so even the LPG is obtained from these petrochemical industry. Sorry, these refineries. Okay. So eventually, these vapors that are released there, they travel up to the Agra, and they were easily reacting with the calcium carbonate, which is actually a limestone, and that is why they were turning this white marble into this yellowish thing. Okay. Okay, so now we come to a very important concept of smog. Everyone knows about smog. Everyone has faced smog. Everyone has lived in these smog, especially I'm talking about the people who are in Delhi or in these big cities or in the nearby cities. Okay, and this problem of smog has now become an annual problem. ठीक है, जैसे annual function होता है ना, उसी तरीके से annual smog function होता है. And in these 3-4 months, especially during the time when the winters have started coming, ये function आपका तेजी से होता है in a form of a festive fervor. एक festivity होती है दिवाली जो उसमें और add on करती है, and then there is another problem of stubble burning which further adds on to this problem. Okay, and we know that we had seen worst of situation of the smog when we found that it appears something like a cloudy situation where there was no sunlight, not because of any cloud, but because of this thick layer of smog. Okay, so there were some curious people around across the globe who used to feel surprised. Okay, how it must have been looking, or it must be appearing, looking at the sky. I mean, with no sunlight because of this smog. Okay, or how, and then it must be an experience from seeing it above the sky, this thick layer of smog over these cities. Okay, so, and of course, thousands and thousands of people were immediately started reporting the problem in terms of asthma, in terms of suffocation. Kids and children, even the animals, they started suffering because of this smog, and the hospitals started filling themselves because of this smog problem. Okay. So what is actually happening in the smog? How is this forming? We will discuss about it in the coming slide. Okay. So for any reaction, especially these air pollutants, it's like preparing your recipe. Okay, we need first an ingredient, then we need a source that will give it an energy, that is like your flame, your gas flame, and then the mixing will there, and then your recipe will be prepared in a form of a food product. Okay, or in your form of your resultant food. So this photochemical smog also, we will understand it in terms of recipe. Forget this complicated diagram, we will understand it later. Let's understand step by step reaction, how it is happening. Okay, first thing, it's the morning time, people have woken up, they have to leave for the offices. At that time, of course, the smog is not there. If you sometimes wake up around some 4 a.m. or 5 a.m., you will see that actually the place is quite clear. अब वो that is another thing कि वो दो पूरे हफ्ते और महीने भर से इतना ज्यादा हो रखा है कि वो उस दिन भी आपको सीन नहीं दिखाई देगा. But if you some means if the impact is not that high, you will see that in the early mornings, the wee hours when there is no sunlight and when people have not woken up, they actually the smog content is least at least levels. Okay, अब जैसे उठे लोग रेडी हुए, now they are leaving for the office, vehicular emission शुरू हो गया. Now vehicular emissions का जो चीफ कंपोनेंट, जो इंग्रेडिएंट चाहिए इसको बनाने के लिए, दैट इज योर नाइट्रोजन. Okay. Now, this nitrogen reacts with oxygen to form nitrous oxide. Okay, which is your nitrous monoxide, or this is nitrous oxide, this NO. Okay. Now this NO, because it still has the capacity to react further, so it can react with oxygen again further with the oxygen to form NO2. Okay. This is usually that is happening daily. Now this NO2 when reacted with water, it leads to the formation of HNO, your HNO3, which was part of your your acid rain. Okay. Now another reaction this NO2 will do is, as the sun will glow and the light radiation will start forming, this NO2 will break itself into NO and O. Now these two are the free radicals. Anyone knows about something about what are free radicals? Anyone? I'm sure one of you must be knowing about
Ma'am,
what are
which
free radicals.
have one electron.
Paired electrons.
Okay, very good, Juhi, very good, Pallavi. Okay, that's good that they have some unshared electron pairs, but that is what makes them very reactive, very reactive. Okay, they are like they are ready to react with anything. Okay, and that free radical generation is actually the source of problem. Okay, because these free radicals now are ready to react with anything. And when now this O free radical, which will force and which will react with oxygen, it leads to the formation of ozone. Okay, now ozone is good if it's there in stratosphere as an ozone layer, but if it's there on the earth, then it's a problem. Okay, beta, one question: is my voice breaking? Should I join again?
No, ma'am, it's
No,
clear.
ma'am.
Okay, fine. So, but anyone who is facing a problem, no problem, try to join again. Okay, I'll join you. Okay, no problem. Okay, fine. So this O free radical, one O free radical, what it will do? It will react with the O2 molecule and it will lead to the formation of ozone. Now this ozone at our levels, means where we are respiring at this level, is highly toxic. Okay, it's not good. It's very toxic. It can react with our bodies. Okay, it can interrupt the metabolic activities of our body, and moreover, this NO free radical will react with the hydrocarbon. Now, what is the source of hydrocarbon? That is also coming from your fossil fuel. Okay, and from the industrial sources. Okay, so this NO free radical, O free radical तो ऑक्सीजन के साथ रिएक्ट करके ओजोन बना लिया. ये NO free radical फर्दर जो हाइड्रोकार्बन्स जो रिलीज हो रहे हैं आपके, वो भी फॉसिल फ्यूल से रिलीज हो रहे हैं, उनके साथ रिएक्ट करके इट फॉर्म्स दिस कंपाउंड ऑफ पर ऑक्सी एसिटिल नाइट्रेट. तो जो इसका नाम है वही इसके कंपोनेंट है. एसिटिल कंपोनेंट है CH3CH2 का, पर ऑक्सी ग्रुप है आपका OO, और नाइट्रेट इज NO3. ठीक, मैंने इसे बैलेंस नहीं किया है, उतना जरूरत नहीं है. बैलेंस आप नहीं भी लिखोगे बैलेंस रिएक्शन एग्जाम्स में चलेगा, कोई प्रॉब्लम नहीं है. बस पता होना चाहिए कि कौन चीज किससे रिएक्ट करके क्या बना रही है एंड हाउ दैट प्रोडक्ट इज रिएक्टिंग फर्दर. ठीक, तो इसमें परऑक्सी एसिटिल नाइट्रेट में कौन सा कंपोनेंट कहां से आ रहा है? ये पार्ट, एसिटिल वाला पार्ट, हाइड्रोकार्बन वाला पार्ट इज कमिंग फ्रॉम हाइड्रोकार्बन्स. This OO free radical is coming from the free radical that is present in NO, and this nitrate part is also again coming from your NO free radical. And along with this also forms certain other, ये तो हाइड्रोकार्बन्स तो बहुत बड़ी चेन होती है. It can be butane, it can be propane, it can be isopropane, isobutane and long chains. तो परऑक्सी एसिटिल नाइट्रेट बनने के बाद में कई सारे हाइड्रोकार्बन के पार्ट जो है वो स्टिल होंगे रहेंगे. They will volatilize and they will suspend in the air in the form of volatile organic compounds. Okay? So किसी भी polluted air का जो composition होता है that is what? CO2, carbon monoxide, sulfur oxides, oxides of nitrogen, volatile organic compounds, hydrocarbon, and then secondary are ozone जो further reaction से बने and your peroxyacetyl nitrate. ठीक है. Now this PAN peroxyacetyl nitrate along with VOCs will react with this ozone. This forms this cocktail of photochemical smog. ठीक, which of course जब ठंडक होती है तो वो water vapors उसको नीचे subside कर देती है, and that is where we are the photochemical smog, we face this or encounter this photochemical smog at our levels. Is there any problem in understanding this reaction? Should I repeat it once more or it's clear to you? Anyone has any question?
No, ma'am, it's
Okay, fine. Good, Anita. Okay, anyone else?
No, ma'am.
Okay, good,
Um,
good, good. Okay. So, after understanding these two phenomena, we will now come to a very, very important thing, which is quite in fashion, not fashion, which we hear quite often. That is ozone depletion, and I am sure everyone must be knowing, is aware of this term of ozone depletion. Okay. तो ये तो हमने ओजोन के फॉर्मेशन के बारे में बात किया एट the earth, that means at our at the surface levels where it's a toxic gas and where it leads to the formation of your peroxyacetyl nitrate. Now this peroxyacetyl nitrate is very, very, very toxic. It's highly toxic. Okay. And it not just affects the health of human beings but it also kills plants. तो जो पेड़ों के ऊपर में अगर आप सिल्वरी कोटिंग आप देख रहे हैं, that is because of this PAN. Then make yourself sure that you are living between PAN and you are breathing PAN or peroxyacetyl nitrate. Okay. Anyway, so now this ozone is important, which is there in stratosphere some 50 kilometers above, from the sea level. Okay, 50 kilometers above in the high in the sky above the sea levels. Okay, so when we say about ozone depletion or something of the ozone layer, and then of course it's the thinning of the layer of the ozone. Okay, and the proper definition says it's the springtime depletion. It's the springtime depletion over Antarctic, okay, and especially over the polar regions like Antarctic. Okay, so I'll come on to that question that why it had happened. Let's first understand how this had happened. Okay, so I think even before 1969 and in somewhere around 1950s, CFCs were invented. Okay, and when CFCs were invented, it was like boom to the industrial revolution because it was very non-toxic. CFCs are very stable; they are non-toxic in nature. Okay, and they were unreactive. They were very stable, and therefore it was and they were cheap. They were not very expensive to be produced. So for industries, CFCs and using these chlorofluorocarbon compounds was very good. So when I say CFC, it's not one. CFCs has varieties of compounds. It has list which has more than 100 compounds. Okay, so these CFCs were then being started using by the industries, and industries started depending, with which they showed huge rise in economic development. Now, in 1969, this chemist Paul Crutzen, he found that N2O is actually reacts with ozone. Okay, and and therefore they are this destroys the layer. Now the question is how this thing came into the head of Paul Crutzen. Now before that, because of course the ozone thinning was happening, uh, uh, because the CFCs were also going and N2O were also going. And why N2O was going? Can anyone tell what is the source of N2 in the stratosphere? Troposphere में तो ठीक है समझ में आ रहा है because of the fossil fuel burning and transportation. What is their source in the stratosphere? Part of it, of course, goes from the Earth atmosphere, but not much. Major part is something else.
Emissions from the jets.
वेरी गुड आसमी. ठीक है, फ्रॉम दी जेट. और उस समय एयरक्राफ्ट इंडस्ट्री में इतना ज्यादा बूम आया था that people were in race of increasing the speed of aircrafts, and therefore they were coming up with the notion of making them fly even above the troposphere and the stratosphere layers, so that they will be offered less friction, they will not be affected by the weather change in environment and weather pattern change, because cloud formation doesn't happen in stratosphere. All the active weather patterns, currents, etc., they all happen at the troposphere level. Stratosphere में कोई weather phenomenon नहीं होता. ठीक है? And when we talk about the CO2 layer or this layer of sheet of a CO2, etc., which serves as a blanket in conserving the temperature of the Earth, that is also there in troposphere, not in stratosphere. Okay, so these jets that were flying, including your Concorde and other industry from the US also, so they were actually giving as a source of N2O to these stratosphere. Okay, so at that time, what was happening? They saw that okay, that the percentage presence of ultraviolet radiation has increased. Okay, now of course there were some atmospheric scientists. They found that this UVC percentage in the light radiation was increasing. So they thought that because of course ozone is that layer which protects them or which doesn't allow these UV radiations to come to the Earth. it implies that there's something which is happening wrong with ozone. What exactly is happening, nobody knew, because so far nobody's no the attention of the people was not diverted to that. Okay. Now in 1969, Paul Crutzen discovered that actually N2O destroys this ozone layer, and from there it was easily associated that yes, there are possibilities, because already they were having the data where they were finding high amount of UV radiations in their in the light radiation coming from the sun, and also because these aircraft projects they were happening at that time. So this was easily connected. These all the dots were connected, and it was found that yes, N2O is actually causing the ozone depletion. And of course, that brought about a lot amount of debate, a setback to an aircraft industry, to some in that, and but yes, this thing of stopping the projects. There were certain projects that were about to happen, they were then stopped, and then only some few aircrafts like Concorde, etc. They were there. Later, they were also um, shut down. This actually happened. But there was another thing which was having even higher potential as compared to that of N2O, which was CFCs, which was still out of the coverage. In 1974, another group of two scientists, chemists, Mario Molina and Sherwood, they actually discovered same role of CFCs in destroying ozone. Now, this was something which was a setback to the industries because they were already heavily dependent on CFCs. So there were debates. So the debates were happening between the scientist community, between the researchers, between the politicians on whether to stop CFCs, how, to what level should they be stopped, and how they should be controlled. So while this was happening in this period of time, in 1985, Furman and two of his colleagues and his team members, they went on Antarctic survey. So by that time, they actually were not aware that this ozone depletion takes place even over Antarctic and Arctic. Indeed, maximum depletion of the ozone layer or thinning happens in these polar regions. Why? I'll be telling you about it in the coming slides. Okay? So they actually haven't went to find the depletion of ozone layer. They went to conduct the other experiments and other findings in terms of atmospheric layers and then the GHGs, etc. There they found that ozone layer has thin, not where they were assuming कि 10% या 20% decline होगा. They found that वो तो 50% से भी ज़्यादा decline कर गया. इतना ज़्यादा destruction हो गया, means it's around 60 to 70% decline was found, and they immediately reported it to the research body. As a result of this, 1985 में Vienna Convention organize किया गया, ठीक, where they discussed about the impacts of and the list of the ozone depletion. Okay, this was then changed. This was उसके basis पर फिर आपका Montreal Protocol हुआ. These protocols and convention we will discuss when we will discuss about the conventions and protocols on the global levels. ठीक है. फिलहाल in 1995, these three scientists, Paul Crutzen, Molina, and Sherwood, they received Nobel Prize for their findings. ठीक. This was the historical thing that happened for the ozone. ठीक. अब तो फिर ढेर सारे Montreal Protocol को follow करते करते तो ढेर सारे protocols and amendments had happened. Okay. So what is happening with the ozone layer? Okay, so the question comes here is when I say that this thinning was observed maximum at the pole regions. The question is why प्रोड्यूस तो ये इंडस्ट्रीज कर रही है दी CFCs जो कि कॉन्टिनेंट्स में है, तो सबसे ज्यादा थिनिंग तो वहां होनी चाहिए, वहां ना होने की बजाय इट्स हैपनिंग एट द पोलर रीजन्स. फर्स्ट थिंग. Second thing, why in springtime this depletion is maximum? Anyone? Anyone has any idea about why is it so? Have you ever thought of it? Why? Yes. Okay, fine. Okay, ठीक है. So I'll tell you. Now, ओजोन की डिप्लीशन के लिए सिर्फ और सिर्फ CFCs and N2O are not just sufficient. There are other conditions, weather conditions that help in promoting the or creating those conditions favorable for the ozone depletion. Okay. First thing तो ये है कि ये जो N2O और CFCs के सोर्स हैं जो कॉन्टिनेंट्स में प्रोड्यूस हो रही है, पोलर रीजन्स में क्यों आ रहा है? Okay. So there is this process known as polar vortex. Okay, I'll tell you what it is. First thing. Second thing, for these reactions to happen, इनको सरफेस एरिया चाहिए जिसमें कि रिएक्शन कर सकें. This surface is provided to them by the particles which forms the clouds there. So now again a question is there कि मैम troposphere में तो कोई cloud formation नहीं होते, then how in stratosphere these clouds are forming? There is this special phenomenon that again takes place as a result of this vortex formation, which is known as your polar stratospheric clouds. And third important thing is सनलाइट का प्रेजेंस होना, क्योंकि जब तक वो यूवी रेडिएशंस नहीं आएंगी तब तक ये रिएक्शंस कैटलाइज नहीं होंगे, विच दे गेट इन स्प्रिंग टाइम मैक्सिमम, क्योंकि अभी तक तो ठंडक था और इतनी रेडिएशंस थी नहीं. बट मोमेंट द विंटर गेट ओवर एंड द स्प्रिंग टाइम कम्स एंड दे गेट द रेडिएशंस, फटाफट ये रिएक्शंस होना शुरू हो जाते हैं. ओके, सो हाउ दे हैपन. Now what is this this for a polar vortex is there. Now in winters over Antarctic, surface is very cool, it's freezing, several minus degrees temperature is there. Now as a result of this, air close to the ground is heavier. Now because of this, because it's cooler, cool हवा होगा, ठंडी हवा होगी surface के पास में, so air stagnates more towards more, it settles down more close to the ground.